My next chapter, which I was going to discuss, called Functional Java. Java has been staying away from functional programming constructs since it started. But the way the other functional programmings evolved Java, based off Java, really made think Java programmers, Java developers, Java designers to think about why don't we make Java as functional? Because Groovy came about, it was partially functional. Then Scala came in. Scala was a big setback to Java. And then Google Guava collections came in, and a lot of other APIs which were based off Java, but they start using functional constructs. That made Java thinkers think that why don't we have these language constructs incorporated into our own language? So the Java became functional since Java 8 release. It's not 100% functional, but I would say it's 85% functional because main traits of functional programming are like higher order functions, currying, monads. They all are in there. I mean, they don't exist the way Haskell and other programming language which are functional from the grassroots levels. But Java did a fantastic job in getting these functional concepts for the programmers. So I'm gonna take this example today, which is a starting point of thinking the functional way. So here the code I'm written here is what happened was there was a class called math which existed in JDK, but the problem was it was returning null pointer exceptions. If we call this method with something which is returning empty, so we call method on an empty object would return a null pointer exception. So here I defined an optional. Optional means it can contain an empty object. It's sort of a wrap around a double object. So this is a small function I wrote, which is a square root of input. We have to give a double input, and it will return value only when this value is not is less than 0. So otherwise it will return an optional empty. So we are wrapping this return value into an optional double, and there's another method here I have defined called inverse. So what this does is it d 1 by d. So it also takes into account the condition. The first condition, this is called ternary operator for those who don't know. So it determines if the value is not equal to 0, then return the inverse, otherwise return only empty. So these are the two conditions Java has. This come up with a new API of math class. So here I have defined. I wrote a test case here where I've returned there are some bunch of values are doubles. So if you see these values are doubles, and then what I did was here I declared an empty list which also contained double values. So there's a small difference here. Here double array, which is of type primitive, and here I have declared an object type double. We'll see what it entails. So here I could have called a stream method on a list of doubles, but I could not call a list stream method on a primitive types. So what Java came up with, there is a double stream of which takes a double array. So it solves the purpose. So then I call a function for each on this stream and pass it a lambda. That means for each double entry into this stream, just write a function, call this method square root on each of the elements. So, and then it's going to convert into a square root of those, and then this method, as we know, returns a double. We have to check a condition called if present. So if present, because it's optional, we cannot get a value directly. We have to place a condition called if present, and then if that results true, then we do this result dot colon add. So this if present takes this is called method reference sort of thing. So result dot add. So that means result is a list has a method called add to the list. So here what we did was we made another, we fill this list here basically. So if present is an important method. So if I go here, if present, you see it, if present takes a consumer double. So any consumer is an interface defined in JDK. If value is present, invoke the specified consumer with the value, otherwise do nothing. Block is to be executed if the value is present. So the consumer is basically it consumes the code. It consumes the code and doesn't produce anything. So that means result add is a consumer. So it consumes the values and fills the list. So there's no output driven here. There's no return value. So this is a consumer. So just bear in mind the consumer. So now I wrote here assertions, so which verifies the list value is 2 because of this function call if present will eliminate anything 0 or negative numbers. So we got 2 here. So here's another definition of function. So here we wrote a function in which the input value is double and the output value is optional double. So this method does basically the same thing which we just did. It takes a lambda. Here we have defined a function, the one in for each. Basically I'm writing it here as a function. So I'm taking this value as a function. The only difference here is I'm calling an inverse D on it. So when I call inverse D on it, it returns an optional. So what happens is when it returns an optional, it's I cannot call because it returns an optional of an optional. I cannot call new math dot square root function call on it. So I have to do a flat map which flattens the map. So I get a value here. So when I call this flat map on it and call this new math dot square root, I get my function here returning optional of double. So because the result of this is also optional of double, I get this function here. So I can pass this function here up to here and I get the same result. So I just wrote this was a demonstration purpose only, and this is another function. In most cases we don't want to deal with optional doubles. We like to have a stream of doubles in most cases. So what we did here was we're trying to see if we can get a stream of doubles here instead of optional doubles, because when we get a stream of doubles we can call it a collector on it. A collector will collect all the stream elements into a list, because most likely we like a data structure which we can work on it. So this helps us get the list out of it. So here we call a new function called f2. This does the same thing. We got d as a double. We call this method inverse on this, and then we do a flat map, and then we call a square root on it, and then when we call this flat map, we have to write a mapper. Basically, Java supplies us there some of the mappers. So what this basically do up to this point here, we got a optional square root inversed product, but we want to convert this into a stream. So basically, it's not a conversion happening here, it's called a mapping. So we're getting from the optional doubles, we're transferring this into a stream of doubles. So this mapping function basically maps like A to B, B to C, kind of mapping. So this is basically a method reference, because stream of, if we call a method stream.off, like we did in earlier examples here, double stream off, we passed a double. So this is basically the same thing happening here. What is happening here is only thing difference is happening under the constructor of this map function. So when you look at this, I will show you map M-A-P. So map, what it takes a function, it tells you about it. Takes a function, any function it can take, and lambda function, as you guys know, can be translated into method reference. So it takes a mapper, basically a mapping function. So stream of also is a function which converts a double into a stream. So just think about those lines. So up to this point, we have a stream of doubles. Stream of doubles instead of optional doubles, like in prior case. We get a. So now, because we have a stream of doubles, we can a stream of optionals here, and then we get we can apply on stream of optionals this method or else get, because optionals can have this method or else get. Now this is, hey stream, your stream of optionals which has a double wrapped up inside, I want to see if you have something, then give me, otherwise give me an empty. So here's another method reference. So you see how functional Java is. We are passing functions of functions of functions all through the lines, and we're getting these products out. So this is high grade functionality, incorporated here. And look at the mutability. Mutability here is thrown out of window, because we're processing a stream here. We are processing on each step the stream operation. Each step is working on the stream from the prior. So here there is no mutability, there's no collection which we are working on. Like, there's no loop construct here where we have to measure an index. So this is great, this is functional. And finally, in this method, we got this function which we have both inverse and square root applied and streamed out. So just wait for an example here. We got a stream of doubles here up to this point, because in the function the first parameter is input, the second is output. So when you write a function, when you see in this angular brackets, the first is the input, the second one is output. Always remember that. And now what I did was I defined a list of doubles. Now list of doubles can be done, called a static as list on these doubles. And then I got the doubles. Now wait the difference here. In the prior example here, I had an array of doubles. Here I have a doubles list, double 2. So now I can call stream method on these because it's a list of double objects. Here we are stream. Here we had an array of primitives. So just bear. There's a minor difference, but this difference could be huge if you don't pay attention. So now we got a double stream method. Now watch this. We can call a parallel on it. This is beauty here. This is beauty because you're seeing a thread API in action. There's a thread pool executors, there's a fork join executors behind the scene working on this in this process. Okay, so multi-threading is a concept of its own, but here you're getting for free. You don't have to write those threading models. And then we do a flat map on it, like we said earlier, because if we don't do that, we're going to get optional, stream of doubles here. So we're going to do a flat map. So whenever you encounter a situation where you have objects inside an object and inside an object, you use flat map, because this will give me a stream of doubles. I just want stream of doubles. So finally, after the flat mapping here, I get a collect method where I can call collectors to list, and finally I get this double product. So this is beautiful functional Java. Wait till my next chapter. I'm going to cover some more details of functional Java concept. Thank you for watching. Have a great day, guys.